And welcome back for part 3. This is part 3 of Basics with Radicals. We're going to be doing a lot of common denominators in this part 3, and we'll continue to approximate and use the squiggle lines. This actually is an approximation math symbol. And we'll start just reminding ourselves, the real basics here. When we add 1/6 plus 2/6, the problem is written in such a way that we can go ahead and add. We have a common denominator, the bottom number, the denominator. And having a common denominator means denominators must be the same. Okay. So if the denominators are already the same, we keep the denominator in our answer. We add the numerators. 1 plus 2 is 3. 3/6 is a correct answer. It's not the standard answer one would see in the back of a textbook or in an article or on TV. The publisher wouldn't usually show this, but we can think of 3 as 3 times 1 and 6 as 3 times 2. And we can simplify 3/6 by dividing top and bottom by 3. Some people call that canceling. Final answer in simplified form would be 1/2. Now 1/2 is exactly 0.5 or 5/10. So either answer is correct, but the answer 1/2 is in the same form as the original problem, and so I would consider that as a polite answer. Okay. Now in a standard textbook, we wouldn't probably see this problem written 1/6 plus 1.5/6. But in some of the ratio and rate of change problems, we might see this could happen. The denominators are the same. We keep the common denominator. We add across the top. 1 plus 1.5 is 2.5. Okay. And since there was a decimal in the problem, it might be appropriate to leave our answer as the ratio 2.5/6. But be able to rewrite your answer so that you don't have any decimals if that's required of you. Now, just like we divided the original answer up in number 1, 3 divided by 3 was 1, we can choose a convenient form of 1. We're in control. We're going to choose a convenient form of 1 or 1/1, any number over itself. And since I can think about twice 2.5 being 5 and twice 6 being 12, I chose 2/2 to help me rename 2.5/6 as 5/12. Okay. Now this third example, the denominators aren't the same, so we cannot go ahead and add right now. But as we've seen in some of the earlier problems on this page, 6 is 3 times 2. And so here in problem 3, again I chose 2/2 to rename my second term, but for a different purpose. Now the sum is rewritten. The sum becomes 1/6 plus 4/6, or a total of 5/6. And so this type of renaming is a strategy for coming up with a common denominator and being able to add. Okay. Now I'll let you stare at this fourth problem. And I had a mistake there, but just ignore that. We cannot add yet because the denominators are not the same. We have a denominator of 6 here, but we have a denominator of some decimal less than 2 here. Now, instructors tell students sometimes that we cannot have a radical in the denominator. Well, it is not, it's not necessarily a helpful form of a fraction, but this mathematical expression makes sense. There's nothing illegal, wrong, inaccurate about it. But before we can add those two terms, we need to rename the second term. We need to multiply by something over itself. And if you will think with me a moment, the most convenient form of 1 for this problem is square root 6 over square root 6. Okay, so I'm rewriting the sum. I still have the first term, 1 over 6, but now I have 4 times square root of 6 over the square root of 36, which will be the whole number 6. Okay, don't be tempted to cancel anything at this point. Just notice that we have a common denominator, and that was our first goal. So to add these two values, we keep the 6 in the denominator. In the numerator, we have the whole number 1, an irrational number 4 times radical 6, and we cannot do anything except write down the sum, 1 plus 4 radical 6, in the numerator. And this would be the final answer we would see in the back of a textbook. I believe so. I guess sometimes we would see, no, I'm not even going to say that. The purpose of these exercises are to find a common denominator, and so that's where I'd leave it. Do not be tempted to quote unquote cancel the 4 and the 6, because that will not work. Okay. So the last problem in part 3 of this video set is 1/6 plus 1 over radical 3. What would you multiply the second term by? Would multiplying by radical 3 over radical 3 be legal? Would it be helpful? It's legal, but it's not fully helpful because we just end up with a 3 on the bottom. But this is fine. If you want to proceed this way, do so. You'll come up with the same answer that I come up with. But what I learned in my in the previous example is that if I had the square root of 36, that would reduce to whole number 6. So this is just me. I'm going to choose square root of 12 over itself. And now my sum becomes 1/6 plus square root of 12 over the square root of 36, which is 1 over 6 plus square root of 12 over 6. I have a common denominator. I keep the denominator 6. I have a whole number plus an irrational number. So the best I can do is write the sum in the numerator. Now the back of a textbook would write this answer with a denominator of 6 as this sum, because the author would have noted that 12 is 4 times 3, and the square root of 4 can be written as the whole number 2. Thank you.